Hi everyone, today we're going to start talking about solving polynomial equations now that we have learned how to factor them. So the difference between factoring and solving is this equals 0 right here. And when we say equals 0, then that means that we can solve and find the zeros, the roots, the solutions, the x-intercepts of our polynomial. So let's take a look. The first thing we're going to do is factor, just like we have learned to do in the last couple of lessons. So I want to look for a greatest common factor, and I can see that I have a 2 and an x that I can pull out to the front. And then dividing everything by 2x, I'll have x squared minus 6x plus 9 left, and don't forget equals 0. So this is pulling out a GCF, just like we've been doing with factoring. We're going to continue factoring, and I notice that this has 3 terms left in the parentheses, so that means that I'm going to use not just quadratic form, but I'm actually going to factor a quadratic because that's what I have left. So we are going to factor a quadratic next. Remember that the 2x, we can't factor that anymore because it's a monomial factor, and that's one of the things that tells us that we can't do anymore. But x squared minus 6x plus 9 can be factored more, and I want to look for things that multiply to be 9 and add to be negative 6, since I have a 1 as an a value. And I'm going to say x minus 3 and another x minus 3, because negative 3 times 3 gives me a positive 9, but it adds to negative 6. We can simplify this a little bit by combining the x minus 3's. Notice that we have 2 of the exact same factor. So we can say 2x and then x minus 3 squared is equal to 0. Now what we want to do is actually use the zero product property that we learned back when we started solving quadratics, and that says that each piece can be set equal to 0, because if the entire thing is equal to 0, either this piece, the 2x, has to be 0, or this piece, the x minus 3, has to be equal to 0. So we'll do that next. We will solve. So 2x is equal to 0, or x minus 3 is equal to 0. When I solve 2x equals 0, I'll divide by 2 and get x is equal to 0. X minus 3 equals 0. I will add 3 to both sides and get that x is equal to 3. So again, this is my solve step, and that is where we set each piece equal to 0. Now, we had what's called a repeated solution. This x equals 3 actually happened twice because I had an x minus 3 squared, or 2x minus 3's. And there's something special about a repeated solution. It tells us something about what happens on the graph. And so whenever a repeated solution is raised to an even power like we had, it's raised to the power of 2, then our graph is going to bounce off the x-axis at that point. So it's either going to come up from below, touch the x-axis and turn and go back down, or vice versa. It will be coming down from above, touch the x-axis, and come back up. If it's raised to an odd power, it's just going to cross the x-axis. So anytime that we have a root that's just happens a single time, or if it happened 3 or 5 times, something odd, then it would be a crossing and not a bounce off of the x-axis. Either way, these are the zeros or the solutions to our polynomial.